Hello friends, welcome back to my another video, and in today's video we are going to discuss class 9 chapter 1 science, matter in our surrounding. So let's begin our video, and before starting the video please don't forget to like, subscribe and share my all video. Thank you. Let's begin the video. So let's begin our video. So the first chapter is matter in our surroundings. So if we talk about the first paragraph, it basically says that everything that you can see in your surrounding, like you can see me, you can see the phone or the laptop you are carrying and seeing my video. You can see that. You can see your walls. Okay, if you are sitting on a chair, like I'm sitting on a chair or sofa or bed, you can see that. You can feel that. You can touch that. Okay, so these things are known as matter. So what is the basic definition of matter? Everything, or sorry, anything that occupies volume or space, occupy volume or space and have mass is known as matter. Okay, like I'm occupying a space in this whole room. I also have a mass. My chair, this chair is also occupying the space, and this also have the mass. Okay, so everything that occupies the space and have mass is known as matter. Okay, now the second paragraph says that in the earlier time, ancient time, the Indian and Greek philosophers, they have discovered the matter have five form. Okay, what was those five form? Earth, air, sky, fire and water. So these five, you can say five types of matter, um, they have built everything. Everything was built by those types of matter. But this was the thinking of ancient Indian and Greek philosopher. But what I have now, what about the modern time? So the modern scientists have classified the matter into two types. First is physical, second is chemical. So in the first chapter, matter in our surrounding, says that we are going to cover the physical properties of the you can say matter. Okay, so now let's start. The first topic of this chapter is physical nature of matter. So matter is made up of particles. Now a long time before, there were two schools. It is given a story kind of thing. There were two schools. One school were thought that one school thought that the matter is continuous. Okay, like I am a matter. I don't have any. I am not made of many particles. I'm just like this only. Okay, I'm continuous, like a block. In Hindi, we called it eat. If you have ever seen, from which we build the house. Okay, so it is like that, a block that eat. So, but the second school thought that the matter is particulated, means it is made up of particles. Now, which school is saying true and which is false, means which school is correct and which is not correct. So to answer it, we have done an activity. So in this activity, we have taken a beaker of water. In that, we have added some salt. Okay, we have added some salt in that. Yes, we have added some salt in that. So what happened that the when we mix that salt, okay, we mix it. So what happened that the salt take the spaces, the salt fill the spaces that is present between the particles of the water. To show this, I'll do something. See, this is our thing. This is our beaker. Okay, this is our beaker, and we are having small particles in the water, which are water particles. Okay, water molecules, or you can say these small things are water molecules. Just a minute. So these small things that you can see, the circle, the round figure, these all are what? None other but the molecules. Okay, these are the molecules of water. Just think, because my drawing on the laptop is not that much good. So these all the are the molecules of water. Now what happened that when we add the salt, okay, common salt or NaCl, when we add the NaCl in it, so what happened that the NaCl particle, which are very small in in C, like you can see the small dot, what they do that they take the spaces that are present in between the water molecules. So what happened that, ouch, sorry, so they take the spaces between the water molecules. So what happened that the when they fill the spaces between water molecules, so the water level did not raise. Why? Because they fill the spaces. Okay, they don't add a layer. They don't add a layer of NaCl on the water or the below the water, but they fill the spaces, the empty spaces. Okay, they fill the empty spaces present in between the water molecule. But when the spaces that is present between the water molecule is complete, okay, when it is complete, what happened that after that, if you still you are adding some salt, you are just adding the salt. After some time, you will able to see that the salt particles are not dissolving in water. Why this happened? Because like you can see in this figure, now you can see that it's like um, the particles of that sugar, or sorry, sugar, or you salt, you can say, the particle of that salt have filled the filled the spaces between that particle, the water particle. So what basically happened in that, that after filling that, the no more particle can not the no more particle can fill the spaces, because it's already filled. There is no more spaces left. So that's why some of salt will remain. You can see the sum of salt, some of salt you can see at the base of that beaker. Okay, so this was the activity, so in which we can, as we all know, salt is a particle, salt is a matter. Why? Because it occupies some space and it also has some mass. Well, its mass is very less, but it still has some mass. Okay, so means that salt is matter, and if it is taking the places between the water particles, means the matter is particulated, means the matter is made up of particles. So this was our first topic. Now let's move on to the this was the first page, you can also say. So the here is the second topic. The second topic is how small are these particles of matter. Okay, so for this we have done an activity that we have taken a beaker in which we have added 2 to 3 crystal of potassium permanganate, and then after that mixing them, we start taking 10 ml of the first beaker and put the 10 ml in the another beaker or the second beaker. So the second beaker is of 90 ml and we have added 10 ml in it, so it become again 100 ml. And what we see that the potassium permanganate colors still present in that beaker. Then we again do this step 5 to 8 times, but after that also we are able to see the potassium permanganate colors. Okay, color, like in this picture you can see it is darker in here, it is darker, then it is getting a little bit lighter, and at at this place, after doing that 4 to 5 times, it is very light, but still we can see its picture, oh sorry, color. Okay, why? So let's take a beaker here. Okay, so just imagine this is our beaker. Now what happened that the we have it is having particles in it. Okay, it is having particles in it, small particles of water again. Okay, now what if we add potassium permanganate to it? When we add potassium permanganate particles to it, and then we take out some water. Okay, you can say some we take out 10 ml of water from it. Okay, and then we add it into the another beaker. So here's our another beaker. Now what we have done that we have taken out 10 ml of water from this beaker to this beaker. Okay, and we add, so what we will see that this is the water level. Okay, the water level is still same, but what will happen that this will also get colored into the color of potassium permanganate. Why? Because the particles of the potassium permanganate are still in this beaker. So as they are still in this beaker, so what will happen that we will able to see its color. Now while that is in this beaker, how they had come to this beaker, they were so much small in size, so that's why to make a small crystal of potassium permanganate it has to be like 1,000 crore particle or atoms of that potassium permanganate to combine and make a small crystal. So by this you can imagine how small the particles of matter are, and these particles are known as atom. So now let's carry forward. So now the let's get to the another topic, that characteristics of particle of matter. So the characteristics of particle of matter, first is particle of matter have spaces between them. Okay, particle of matter has spaces between them, like right now I am in this room and this room is with filled with full of the gases. Okay, so now let's take a another beaker. It is water. Okay, this is water, and what we let's see the particles that are present in that water, how they are looking if we see it in under, you can say, microscope, electronic microscope. So the particles of the water will be like this. Here's one particle, here will be one particle. Okay, there will be a lot of particle in that. Okay, these are the particles that are present in the water. Okay, so now you can see that there is little bit spaces between the two particles. Okay, there is spaces between two particles. How? Like see this particle, as you can see my cursor, and this particle, there is some space. Okay, there is some space between them. Similarly you can take this particle and this particle, there are also some spaces between them. Okay, so like this liquid has some spaces. What if we talk about solid? Okay, what if we talk about solid? Just think this is our solid, and I'll write here solid. Okay, this is my solid. Now what will be the state of the particle that is present in the solid? Okay, now let's see it. Mm, yeah, okay, the state of the particles that are present in the solid will be like, I will make it a little bit larger, okay, to understand clearly. And yeah, my drawing is not so good on the laptop. So they will be like this, they will be attached with each other. Okay, they are touched, they have the intermolecular spaces between them will be negligible or very less. Okay, still they will be having, because why? Because particles or atoms, ouch, because the atom is, you can say, circular. Okay, so if we will attach two balls with each other, still we can see. there will be some gap, so the gap will be presented there, but it will be negligible. Okay, means the gap is present there, but it will be very less. Okay, so means this is the solid. As you can see, its particles are very close to each other. Well, if we talk about the gases, okay, let's go a little bit down. If we talk about the gases, the particles, the particle in that would be like that much far. Okay, the particle will be this much far from each other, so you can see there is a lot of distance between them. Okay, if we talk about solid, there is almost no, or you can say negligible space between them. If we talk about water, there is little bit space between them, and if we talk about the gases, they have a large space. See this, how much space it have. Okay, so this is the first one. And if we go to the another one, the another characteristic of particles says that particle of matter are constant continuously moving. So okay, so now how they are moving. If we talk about solid, we all know vibration. What is vibration? Okay, or not, we will study in it physics. So we all know about vibration. It start vibrating. Okay, so means every particle, every matter is vibrating. Okay, solid is vibrating, liquid is vibrating, or you can say continuously moving, gases is continuously moving. But the only thing is that the solid is almost vibrating, or you can say moving with very negligible speed. Liquid little more, and gas most. Okay, air also flow, and we when in the summers the air flow, we also see, we also feel cool. Okay, so air flows. The third is, and the third one is every particle attract each other. Okay, that's why the solid particles are attached with each other. Liquid have little bit low force of attraction, and gas do not have any force of no negligible force of attraction. Okay, so this was all for today.